Hi guys, Glader here. So today I'm here with another Spyro and Unity 3D update, and this is going to be about how you can achieve good performance in Unity 3D, especially with the imported Spyro content from Glader Spyro's tools, which are free open source tools that allow you to bring in content from Spyro World Viewer and set it up in Unity with no modeling software required. So here I have a scene of Summer Forest in Unity, and go ahead and go to the game view if you're going to follow along, and go ahead and click on the stats tab at the top, and let's take a look at what's going on here. First and foremost, I have to tell you that we're in an absolutely awful state right now. This is like the worst case scenario. We've got 700 draw calls right now. Almost exclusively, the issues that you're going to face with performance for the Spyro content, and a lot of content, for example maybe VR chat if you're uploading stuff, it's going to be draw calls. You're never going to be able to saturate the GPU with enough stuff to do in almost all cases. It's going to be the CPU limitation with batching and draw calls. Now, you could probably get away with this because it's still only 700. I know I say only 700 because we're going to get it down to 7, which is several orders, 2 orders of magnitude smaller or less draw calls, but still not the worst. You could still actually run this, but you probably couldn't on mobile. So the first thing we're going to do to address this issue is we're going to select our water, our level, our skybox, and any portals we have. And when you do that, you won't be able to see the individual settings that you may or may not have set up. But what we're going to do is we're going to make this batching static. That's going to solve actually most of our problems. So we'll go ahead and set that. And now when we actually run the game, the majority of this is going to be batched. But actually before we do that, let me disable batching and show you the frame debugger, which is a great tool to get you, familiar with what's going on. Alright. So we're running the frame debugger, and we can take a look at what it's doing. So doing a bunch of depth stuff here that I can't even see. Then it's doing a bunch of depth normal stuff. Then it's doing opaque geometry, shadow rendering. Then it's doing some actual rendering, the mesh rendering, and that's rendering the sky. And it's doing some post at the bottom. That's 700 draw calls. Now we can get this down to 7 because a lot of these long stretches of draw meshes can actually be batched. And that's what we're about to do. Let me go ahead and collapse these. So we're going to go ahead and go back to the inspector and make these batching static. So now when we actually run this, the majority of this is going to be batched. And if we look over here and we run the frame debugger, did I accidentally disable it? Oh yeah, I totally forgot. I actually disabled some settings. So what we're going to have to do is go to File, Build Settings, go to Player Settings, and scroll down a bit under Other Settings. Now this should already be checked for you guys, unless you for some reason disabled it, or another person you're working with has disabled it in the project. You want to have static batching and even dynamic batching enabled. That's why we weren't seeing any results. That shouldn't really be disabled. It should always be enabled, and it's the default. But that's why I actually disabled it before recording the video, so I can show you the worst case. So you probably will never encounter that worst case, which you should be thankful for. Alright, so now we've gone from 700 draw calls down to 260, with 500 of them being batched. So let's go ahead and check the frame debugger and see what's going on now. Alright, so we do a depth normals texture. This is what I've been complaining about in several of the other videos. This is something that happens in both the forward and deferred path, even with batching enabled. It has to draw these individually. I consider this the default in Unity 3D, personally. And the reason that we're actually rendering this is for screen space ambient occlusion, which we'll get to a little bit later. And then we do some, I think, some shadow stuff, but that's batched now, thankfully, so it's very short. and then we do some rendering that can't be batched because of real-time shadows. It tells you over here why something can't be batched. And then we get some, I don't know what that is. And then we get some stuff down here for transparent materials, and then some post stuff. Okay, so we're down to we're down to 250 or 300, whatever you want to call it. But we can actually get to like 7. So we're going to take this further. So one of the things, and it's kind of disappointing to say, is you can't really, at least with it being imported like this, you can't use this screen space ambient occlusion that relies on the depth normal texture. Even in deferred rendering path, I've noticed it won't work. Which, by the way, for Spyro stuff, use forward. We're going to use forward, okay? I can't really spend a whole video talking about the forward rendering path and why we need to use it, but the Portal implementation, I think, relies on the forward rendering path. Forward rendering path is more performant, and we're not using any lights other than the directional light, which is like the sun, and so forward is best. So be in the forward rendering path as well. Man, I really don't plan these videos out at all, so you really just, you're getting them first take, sometimes second take. So we're going to go disable ambient occlusion, and that's going to solve quite a few of our problems. So we'll go ahead and run this. And you can see now we now only have 100 draw calls, so we're getting better. Well, let's go ahead and take a look at why with the frame debugger. So it says here different blah 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 receive shadows, blah 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 blah. We get some shadow jobs here. We get some transparency crap down here, and we get some post stuff. Now I'm gonna go ahead and disable our color grading, which isn't for performance reasons, just so a change we make later won't be so drastic looking. Because I don't want you to think that's you lose everything by doing that. So this is what it looks like without any color grading or anything like that. Okay, so how do we get down from 100 to 7? Well, I can't make the video long enough to talk about light mapping, but we're gonna bake the lighting, because if we actually run this, I'll go ahead and show you why. It's not a directional light that costs anything. In the forward rendering path, and even the deferred rendering path, directional light is essentially free. It happens on the forward base path, or pass, and so it's actually the shadows. So as you can see, we're down to like 31 without the shadows. Now, I'm not going to show you the frame debugger for that, but you can just see the batches change there. Oops. Yeah. So what we're going to do is we're actually going to bake the lighting, which Spyro's, the shaders that I've written support this, and I've already generated this, so hopefully it should just run through and then set some stuff, and we'll go ahead and take a look. Okay, great. That went way faster than I hoped. So let's go into the scene view, take a look at the bake light map. So we actually do get some interesting things from bake lighting. We actually bake the directional light data in, but we also get some indirect, which is some bouncing. You get some nice, different like, it's hard to tell. You can actually tell the difference here by clicking this button. So it won't just be like one ugly thing. There'll actually be variation from the lighting. Actually, let's turn off that too. So you'll see areas that should be darker will be a little bit darker. You can see a little bit of shadowing differences, especially over here with the trees. Maybe not so much. Actually, I'm going to clear this. Yeah, so that's what it looks like without. And so you don't get a huge nuance. But you actually do get a little bit already, because that's just how they were painted. The vertex colors were painted, so that's pretty interesting. So let's go ahead and add these again. Boy, this video's long, but I can't help it. I'm trying to fit so much material into this single video. So to help you guys get down to what level's required to render this on mobile. Alright, so let's turn this back on. So now with all this stuff baked, let's run it. And you can see we have 33. So let me show you something in the frame debugger that's going to be interesting and important to you. Static batch. Okay. You can see that it doesn't render all at once. And the reasoning for that is that we have, if you scroll down in the lighting window, we have 3 directional light maps. So in Unity 5.x in 2017, things that are targeted that have different light maps, like if you check the global maps, you can see those. They can't be batched together. I think this has changed in 2017 or 18, sorry, but we're not using that yet. And so one thing you want to do is keep your resolution low for so many reasons. Keep your resolution low so that way you have less maps, you have less lighting data, and of course you lose some quality, but it won't be that big of a deal anyway. So that's why we've got a couple batches there. We've got a couple here with our water and stuff, but these are all different materials. They're all in the transparent queue, so some of them can't be batched. And then we've got some post here. So we're at how many right now? 33. That's pretty good. So let's go ahead and just disable our post. Now there's a few things in post that you saw in the frame debugger towards the end. These are all post. Has to do some stuff. Has to do some sampling. I don't know what's here. Is that upscaling? I have no idea. I really don't know. But if we disable our post, we don't lose much because we already turned off our color grading, which wasn't a huge deal anyway, and the ambient occlusion, which was a huge deal. And there are ways that you can do some screen space ambient occlusion with the Spyro content, but that would require you to manually combine meshes and batch this yourself. So wow, we're down to 19. That's pretty good. We come down here, we're like 8, 11. But how did we get 7? That's the major question. Because that's what I was at earlier. And the answer is, I don't remember. So I'm forgetting something. How did I get down to 7? Static batched, motion vectors. Oh, yeah, so we shouldn't need those after we disable this post. So let's go ahead and run this now. Yeah, and now we're down to 6 and 7. Depends on what direction you're looking in, because some areas have some different materials on them. We go down as far as 5, 6. That is 2 orders of magnitude better, and that makes this, as far as the CPU side is concerned, makes it mobile ready. The shader's a little heavy. We're using some really high resolution uncompressed textures right now, so you probably can't just put this on mobile right now. As you can see, much higher resolution than in the game. But that's something that can be changed. But really, this is ready for mobile. I mean, far more than it was before. So you can slap this on your last generation iPhone or Android device, and you should be good to go. And yeah, this is how you essentially go from the worst case draw calls to pretty much the best case. It helps a lot that Spyro content comes in Atlas. That means we get to use the same material for a lot of the stuff, which is a big part of batching. I'm not going to go through a whole tutorial on how things are batched and what you can do to achieve better batching. So you got to go read up on that. But they can be batched because they're using an Atlas. Even though we don't use an Atlas anymore, we use a texture array, texture 2D array. But it's essentially the same thing. It's just flattened out. It's for like, I won't get into why. I have a video on why we're using that. But yeah, that's the video. Kind of long, but it's kind of sort of a crash course on how to go from terrible performance to pretty good performance. And this applies to general Unity stuff as well. This applies to stuff like in VR chat. And you go from the render thread taking 1.5 milliseconds to 5 milliseconds. And another thing is that we didn't touch on, but it's not such a huge issue because most of the stuff can be batched here. But occlusion culling is pretty important too. Let's go ahead and run this without culling on. See that we have to render a lot more. I think dynamic culling is enabled. So as you can see, we have to render 13 vertices, 24,000 verts here, which is the main performance bottleneck for GPU rendering. But we're never going to saturate the GPU with enough work, even on probably mobile. So just remember this number, 25K here. Let's go ahead and we'll go ahead and bake. So go look into occlusion culling. It's pretty important. It's tough to visualize it unless you move the camera. It relies on the main game camera. So we can do a visualization from here and switch to occlusion visualization mode, and you can see that it's culling quite a bit. And so this also works with batching. So now if we run this and we go over here, wow, look at that. We're literally only doing 650 vertexes. 650 vertices. Yeah, that's so cheap. That's so cheap. Some old lady's old phone could probably do that many vertex processing at 60 frames in 3 batches. You know, that's pretty nice. So occlusion culling is important, but it was mostly related to batching, avoiding the fault with depth normals in screen spacing and occlusion in Unity, which I don't know when that's going to get fixed. I've complained on Twitter, I've complained on the forums. There's no solution other than manually combining these meshes into logical chunks, and then you won't have to pay such a large penalty for the depth normals. So yeah, that's pretty good. Wow, 650 vertices, 3 draw calls just looking at this, compared to the 700 that we had earlier while we were up here. So that's the video. This will allow you to bring Spyro content, and really any content, as long as you do the other stuff I was talking about onto mobile. You know, I really like performance lately. It's been my thing for the past few months because of VR chat, and having to get stuff on VR chat rendering on VR, you know, has been quite a process. So one other thing I can say is avoid in the forward running path any real-time point lights. Okay, I didn't touch it on this video, but that's another thing you need to not touch. No real-time, not point lights, pixel lights. No real-time pixel lights. Change them to vertex lights if you have to. They don't work with light mapped objects, but yeah, that way you don't have to cause draw calls per object they touch, which, ooh, that could get horrible. But I'm not going to show you what happens if you do that, because this video is already long enough. So thanks for watching, guys. I hope this was interesting. I hope you learned a little bit about Unity and how to render Spyro stuff in an optimized fashion. Now let's go ahead and turn the post back on for one last try. We'll pay a little bit of a penalty. Turn on color grading because, ooh, it just looks nice with color grading to me. And wow, so only 20 draw calls. Could be worse. Yeah, so I'm pretty satisfied with this. We can get down all the way to 7. And for this desktop, if you want to use some post excluding ambient occlusion, or at least the screen space kind, then you can get to 20. 20's not bad. 20's pretty good. So yeah, thanks for watching, guys. I'll see you guys in the next video.